Sound design.
So if you just put one mic in front of house or one mic in front of house and one 20 feet off stage of that, the likelihood of any cue choice not being representative of the audience is really high.
Sound design. Sound Design Live is produced independently by me, Nathan Lively, in Minneapolis, Minnesota. Welcome to Sound Design Live, the home of the world's best online training and sound system tuning that you can do at your own pace from anywhere in the world. I'm Nathan Lively, and today I'm joined by product manager at L-Acoustics, Scott Sugden. Scott, welcome to Sound Design Live.
Hey, thank you, Nathan. I really appreciate you having me here today. I'm looking forward to our conversation.
Well, I definitely want to talk to you about all of the great things you're doing at L-Acoustics today, and you also do a lot with sound system tuning, optimization, design. But before we do that, what did you dress up as on Halloween yesterday?
Like all of us in this industry, I dressed up as a roadie, so I wore a black t-shirt and jeans.
Were you a disgruntled roadie? Or?
Yeah, no, I was actually a happy one. I had a beer. It was after the show. So
Nice.
I have 3 little children, and this year my wife and I did not get dressed up, unlike years in the past where we've been all coordinating with the children.
Okay.
But as our children get older, we are now able to move on to the stage and trick or treat where the kids go run around and we sit and drink a beer. So
Oh, nice. That's the best. All right, Scott. Well, tell me about how you got your first job in audio. Like, what was one of your first paying gigs?
Paying gigs? Well, I don't think I got paid for a long time because I actually started doing sound in high school. I'm kind of lucky. I ended up, by chance, my family, we lived in a city that had a performing arts school, and one of my older stepbrothers, actually 2 of them were on stage singing in the musicals, and I didn't want to be on stage, but I decided I wanted to do sound. So I started mixing shows when I was 15, 16, the high school musicals and that kind of thing. And I'll say my first gig, like outside of the musical where you're just kind of surviving and doing the show, our school had a good jazz department. And actually the very first band I ever mixed in my entire life was the Count Basie Orchestra. When they were 16, they played my high school.
Oh, wow.
When I was 16, pardon me. But they came to the school and played there. And what was interesting was, obviously, I knew nothing at the time, so the musical director told me to put a mic in front of the soloist and mic in front of him, a mic on the snare and an overhead, and don't touch anything. And so I successfully didn't touch anything for an hour, and they performed. And we had a good show. But that was the first band I ever mixed. And I think I finally started getting paid at about 19, I think. My first summer gig through between years of university was at Clearwing Productions in Milwaukee. And my dad had randomly met the shop manager at a wedding and said, "Oh, my son does sound for bands in college." And they said, "Oh, well, we need some cases put in a truck." And so as many of us in this industry, you start by, putting the cable in the case, and eventually you get to put the case in the truck, and eventually you get to take the case out of the truck, and eventually get to take the cable out of the case, out of the truck at the gig, and next thing you know, you're mixing sound at a show.
Yep, and as I can report, that happens every time you move to a new city as well, so you kind of have to work your way up every time.
Yeah, exactly. So yeah, it was quite good.
And was that the moment when you kind of knew, like, oh, maybe this could be a career? Or did that come later where you thought, oh, this isn't just for fun, maybe I can make money and support myself?
Yeah, I think I went to university actually thinking I was studying physics. So I went my first day at university. I thought I was going to be a physics major, and that was the beginning. And I'd done sound, but I'd never thought from high school to university that I would be doing sound at university. But it happened that my neighbors in the dorms and my roommate were all music majors, and we went out to lunch that first day and started introducing each other, and they're talking music and classical and orchestral, and I don't know that world very well at the time. And then they started talking jazz, and I mentioned the different jazz bands I mixed that came through my high school, and they're like, "Oh, well, that's kind of neat." And it turns out that the neighbors had a band that had a show the next day. And so I did their concert at the university campus in front of a pair of towers.
Oh, wow, your first day at school.
Exactly. And what's fun about that is it's a 9-piece university jam band nothing extraordinary about that part of it, but it was a great group of people that became great friends. And that day we're doing sound check that very first time, and I had done enough sound checks to know how to do them. And I'd mixed enough bands at that point at 18 or 19 to know how to mix a band-ish. And I was a cool sound guy. I had my own set of headphones.
Yeah.
So yeah, exactly. I mean, I'm living up in life there at 18. And I brought my headphones to that gig in front of those towers. And the lead singer is up in front of the mic singing and playing his guitar, and we're getting it going. And just then a football player from the team jumped on stage and grabbed the mic.
Oh, no.
And I reacted by turning off every fader, muting all the channels.
Wow, you're fast.
Yeah, exactly. And he grabbed the mic and started talking. It didn't work. And I stood up behind the console and pulled out an XLR out of the back and pretended like I was plugging it in and made my hands all confused and not knowing what's going on. And as soon as he gave up and put the mic back and stepped off the stage, I turned everything back on. So I think, in my mind, this player was midair off the stage when the lead singer, who is Justin Vernon,
doubled in the toes and exited when it closed in the morning.
Of Bon Iver at the time, or now I should say, was saying check 1 2 out of the mic. So that's how I met.
That's funny.
That's how I got started. And Justin and I built our first studio together for that band in the next year and record. We realized we were going to record an album, and it's like we could go to a studio or we could build our own. And it turns out that was about the same amount of money. So we just built our own studio and spent several weeks recording that band's next album. And then it was about the same time I started getting paid to do sound. When it wasn't with them, because we were just college kids who were broke. So our idea of a weekend was we got $300 to play a show, and we all got to eat and drink that day for free. That was probably the extent of our happiness. So,
wow, interesting that you two met so early on in your college career, and now you've both stuck with it, and reached great places in your career. I'm wondering if there was anyone else in that group in that school that's also now the president of some arts organization or something.
Yeah, actually, it's interesting. There are, from that core group, there's a number that have stayed professional musicians, successful musicians on their own right. Brad Cook is from that group, and Brad Cook has produced records for War on Drugs, Bon Iver as well, and others. Phil Cook, his brother, has got a number of different bands that plays. Joe Westerlund is another friend from that group that is a professional musician as well, among others. And so easily half that group has stayed in the music industry and makes a living from it, which is great to see. Because it's not the way most university bands turn out, right? Mm-hmm. Most of us, it's a hobby. We enjoy doing it. Most people who start doing sound at 16, it's a hobby. They enjoy doing it. But the fact that nowadays myself and Justin get to cross paths twice a year somewhere in the world at a festival or at a show. I'm working on one end of the stage, and obviously he's working on the stage, and it's a lot of fun to see old friends in ways like that.
Yeah, and that's the second time I met you. So the first time was at Infocom, and then the next time you were in Minneapolis for one of the dates on the most recent Bon Iver tour, and right. You were here in the capacity of basically making sure that this new L-Acoustics rig was I think being set up and tuned properly. Remind me?
Exactly.
Yeah,
exactly. I mean, I jokingly say I was there to kiss babies and shake hands, right?
Looking good.
Yeah, exactly. If I've done a good job, and my team and our team here have done a good job of educating people on how to do proper sound design and how to mix in this new immersive hyperreal way that is Eliza, then there's not much for me to do there. So I'm just the insurance policy to answer questions when we get into weird places.
Nice.
And so for that show, I came up just to get them going, but they had already done a week of production rehearsals. They had already done one show in Eliza, but this is the first date of their arena tour, and this is the first large format arena tour they've done in North America. So.
Right. Cool. Well, I was glad I got to be there to hear some of it. It sounded great. And thank you again for showing me around. We're going to talk more about Eliza in a little bit. I'd love to wrap up this conversation about kind of your career and how you got from there to here. So I know there were probably a lot of things that happened along the way, but I wonder if you could maybe pick out one of them. So looking back on your career, do you think there was maybe one decision that you made to help you get more of the work that you really love?
Yeah, I think there's a few points along the years that obviously changed my course and my path. I remember early on studying physics and first starting to do live sound, and I worked for a sound company. Milwaukee Clearwing is a great company, and they have a lot of great equipment, but they were one of the early adopters of VDOSC. And I remember starting to learn how to put up big sound systems. And for me at that time, I didn't have all this unknown knowledge or this historical knowledge of point source arrays that we used to use 25 years ago. So I didn't have to unlearn that. And so I looked at VDOS versus an 850 or versus another trap box rig, and it made perfect sense we should use a VDOSC. And I realized that, and I started to want to learn more about all those things, and that helped really grow my career the first few years. But I think at some point I realized I had to step out of being at just one company if I wanted to have more opportunity. And so the decision to go independent of a single company was a scary thing in life, right? I'm committing to not a steady paycheck. I'm committing to not consistent work. I'm committing to all those things. But yet I'm giving myself opportunity to be in newer, higher, and more important places. And that was definitely a scary point in my life. That was 2004-ish. I left Clearwing as a full-time employee and started doing freelance. And I got lucky. I mean, the very next thing I did was the first national tour of the Broadway show, The Producers.
Okay. Sure.
So it was just an easy first jump, right? And over the years, then I toured with a number of different artists and did a few different Broadway shows, and also still worked for different rental companies along the way until eventually I ended up here at L-Acoustics about 10 years ago.
Scott, I have not used almost any L-Acoustics in my career until now, but I just moved to Minneapolis a couple of years ago, and there's a lot of L-Acoustics here. I just have noticed a lot of the companies in this city that kind of have them in their inventory. So I know it's going to come up at some point. So I wonder if you could help me prepare. I don't know if you can speak in a general sense just about all of the products, or maybe you could think of one or two, but what do you think is some of the biggest mistakes you see people making who are new to L-Acoustics systems?
And this is probably a fairly agnostic answer. It's not necessarily an L-Acoustics one, but I think it's a common mistake made with a lot of sound systems is the expectation that you can solve your problems of a bad design after you install it. Right? Uh-huh. You can solve a bad line source array deployment with gain shading or equalization. You can solve a bad sub placement with time alignment. You can solve a bad coverage choice with front fills, right? And so that's a mistake I see, obviously quite universally, and it's no different. L-Acoustic systems can be deployed just as poorly as anything else. And so usually those mistakes are made from the front end, and either that's through a lack of preparation, information, or knowledge. The lack of preparation is one that you can overcome, right? You can take the time to prepare, right? The lack of information you can overcome, and you can be aware of both of those aspects. But the lack of knowledge is hard to be aware that you don't know something, right? So that's one that only comes with time, experience, and making mistakes. So to me, it's like avoid the first two. Don't ever have a lack of preparation. Be ready to go. Know your gig. Know your schedule. Know your load in. Know your assignments. Know your pivots. Right? Hey, this is going to have to go down stage. What's my pivot? This is going to have to move over here. What's my pivot? How do I change that? A lack of information, seating charts, room designs. All of that is things you can do. Unfortunately, you don't know what you don't know, and that's something that you'll learn. And as long as you learn and don't make the same mistake twice or three times, you'll be a highly successful sound system provider, system designer, system tuner. But for me, it's the lack of preparation.
Right.
Walk in, not have enough speaker boxes, and not present that fact to people on the front end. Up in Minneapolis, you can use a lot of Cara and K2, but you should never expect that half the required PA is enough to do the show successfully. And if you have half the PA, it's really important that everyone is aware of that far in advance, so that when we get there and everyone says, why is this not good? You can say, because you said I couldn't have more. Right. And that's, once again, that's brand agnostic. That's true of any other loudspeaker system as well. If you don't have the right amount of equipment, it's going to be hard to be successful.
Yeah, I think I've heard it said that your system optimization can only go as far as your system design. Which is, I think, one of the first points you were making there.
I can only successfully hit the objective. I can't necessarily make it much better. So mains to subs, if you have a bad subwoofer design, time alignment isn't going to fix it, right? It turns out that that's baked in from what you've chosen. You can't retime a bad placement in that sense. You can pick a new place to optimize it, but it's still going to be bad in every other spot after that. Mm-hmm. So that's that information and preparation side, right? Like if I chose to prepare poorly, or I was unfortunate and prepared poorly, it's going to be a bad outcome.
You and I met for the first time when I attended your demo at Infocom, as I mentioned earlier. One of my favorite parts from that demo was where you were showing off some of the system measurement parts that you have now in the P1 processor. And what's interesting for me is how you have started incorporating some automation into this stuff to try and help us sound engineers save some time, maybe make less errors, on the human side of typing in numbers and like the process and where do we put the microphone. So I thought, wow, cool. You could actually save a lot of time if this works well. So I wondered, for those people who couldn't be there or maybe haven't experienced this, could you walk us through one or two of those procedures and maybe why L-Acoustics has decided to pursue this kind of maybe automation or shortcuts, if you want to call it that?
Yeah, I think that's a great way of putting it, and asking the question. What you're describing to your audience is a piece of hardware, which is what is called a P1. So this is a network AVB processor. It's a front house processor. It's got EQ buses. It has 20 inputs on it. So analog AES, AVB, and mic pre's on it. It has 16 outputs, AVB, analog, and AES. And it does a couple things for us. One is it converts audio to AVB for transportation to the amplified controllers that we use to power our K1 and K2 and Cara and so on and so forth. It functions as a front house EQ station because almost every show you have a device like this. But it also is now the microphone preamp for data acquisition for a measurement platform, which is integrated directly into the controller software that controls the DSP. So we have an amplified controller software called LA Network Manager that controls and manages the amplifiers and the P1, and it's now also the measurement software. So the measurement software within that is called M1. It's a really technical code name for measurement software number one, and it turns out it made it through code name and stuck as the product name. What's neat about this is not that we have a measurement platform, and it's not that neat that we have a really great front house processor with a preamp on it, but it's the tight integration between your DSP platform and your measurement platform. So they're now one software. And what this allows any systems engineer or front house engineer to do is actually take a measurement and also at the same time know the state of the entire DSP system. And through the magic of post-processing and computers, we can change the EQ without having to make any additional sound and see the results on every single measurement you've taken that day. So the P1 has 4 mic pre's. We can actually take a measurement of the house left main PA in 4 different points at one time. But because we're in control of the DSP, we can also automatically mute and unmute the subs, the mains, the front fill, and organize all that, database all that, name all that automatically, so you don't have to do the busy work. You can move the mics to a new position, take another set of measurements, once again automatically naming, muting, unmuting, recording. And then without making any more sound, you can set an EQ at 250 hertz and see how it affects all 8 of those mic positions, even though you've not actually made any more sound or had the mic there at that given time.
Yeah, cool.
Yeah, it's really neat. And the power here is that tight integration between the two platforms. So post-processing a measurement is existed for some time. Post-processing a measurement and then automatically loading it into the DSP is quite interesting. But then also taking control of the DSP for the measurement process. And we've added a few other tools to make your life easier. One is an automator called Auto Align. So it automatically finds the best alignment between multiple sources. So mains to subs would be the most obvious example. It'll find the best summation between them by both looking at the magnitude response, the phase response, and the impulse response. Because often we accidentally time align mains to subs and inadvertently end out a wavelength at a time. Mm-hmm. That's a pretty common mistake for people. You look at the phase trace and they look really lined up at that 60 hertz crossover, but it turns out you're off by a wavelength when you've gone the wrong way. And so this tool will help make sure that that problem doesn't happen. Obviously, with a lot of automated tools that we'll talk about today or in the future, we want to make sure that we always leave the user in control so they can select the best alignment according to the algorithm. They can always tweak from there to find what is the optimal result. What's neat in this alignment tool is that it looks at the alignment at a given position, but it also displays the quality of the alignment at all positions simultaneously. So you can see if my time alignment choice today is good for all 12 of my microphone positions, or if it was only good for the one position, i.e. I made mix sound great and it sounds terrible everywhere else. Or I might need to sacrifice mix a little bit today for the benefit of more of the people in the room.
Interesting. So if I make a change here, how does that affect all the other positions that I already measured earlier today?
Yeah, exactly. And that's exactly what the tool does. And it does all this without making more sound. So we don't have to continually run pink noise. On top of it, we're doing a data acquisition. Instead of pink noise, we do an impulse sweep. So it's a 2 or 3 second chirp through the PA. It's got a pretty good signal to noise ratio capability, so it doesn't generally have to be as loud or as long. And usually in most applications, we can do that without having to have dedicated quiet time. Mm-hmm. So I think of the corporate event or special event scenario where on a mid-sized corporate event, we usually get like 1 hour of dedicated quiet time where they split lunch, right? The audio team stays and the lighting and video go off for lunch, and we get 1 hour where we can be obnoxious and loud and do whatever we need to. But that's kind of it for the day, right? That's all we get. And if we can actually do most of our design process and do the alignment and design, and then we can get on site and measure it and verify it and tweak it before we even get to that quiet time we can actually put a person up at the podium and have them talk for 30 minutes and really hone it in.
Right.
Because most corporate events, you end up, the first 45 minutes of your alignment time is spent time aligning. And then the last 5 minutes, you throw someone on the podium real quick or on the headset. And oh yeah, we're good to go. We're ready for rehearsal in an hour.
Yeah, that's great. So it really allows you more time there to feel confident that the choices you have made all along the way now actually sound good with real content coming through the system.
Yeah, exactly. And we're developing a training right now. It's to help people learn more about what aspects of system tuning you can actually do really well on site versus what aspects are challenged. So actually just did a presentation at AES last week about that, and we've got our first paper about where to put microphones in the room. So there's an AES paper about where you should place microphones to get the best representative average of the room.
I was hoping you were going to talk about that. So you told me the story when I was in Minneapolis about how you had this question come up where you're like, I wonder, what if I could place a microphone in every seat in an arena? Wouldn't that give me the best information? So yeah, would you share that story?
Yeah, it's an interesting quandary. So I think of system tuning as the exact same process as a political poll. So not to draw into a discussion of politics, but let's use that as our analogy today. Political polling uses a representative sample of the American demographic to figure out who's going to be the next president or governor or so on and so forth. To do that, they have to figure out what is representative. And we need this many of these people, this many of these people, this many of these people, and that represents what we think this looks like. When we do a system tuning, we actually are trying to do the same thing. We're trying to get a representation of the audience. And the true representation would be one microphone in every single seat averaged, right? But that's not practical. So the question is, what is practical? What is representative? How many positions do I need to be representative? And so we've actually done a study on that, and we've published that as an AES paper. And the challenge is if you select X number of places at a pseudo-random way, and how likely is that is a good representation of the actual reality? Turns out about 8 microphone positions distributed evenly in the center mass of a coverage of a loudspeaker is pretty representative of the overall. The likelihood of a poor EQ choice because of that is pretty low. And it doesn't get much better with more mic positions. So you double that or triple that or quadruple that, you have 32 choices of mics in the center or in the coverage map, and it's not going to improve your odds much. However, if you only do 1 or 2, the likelihood of a poor EQ choice is really high, right? So if you just put one mic in front of house or one mic in front of house and one 20 feet off stage of that, the likelihood of an EQ choice not being representative of the audience is really high. And so that's that's that first step. The second thing I think we talked about a couple weeks ago in Minneapolis was about the likelihood of a measurement being representative in response. Mm-hmm. So you have one being, does this group of microphone positions represent my audience? And the next is, does this actual response represent the reality of the system? And for that, we've done some study on that as well. And we actually have taken measurements outside in atmospheric conditions that are good and found that, for instance, at 80 meters, our plus or minus from measurement to measurement on average is about 5 dB, plus or minus 5 dB at 10K. So at 80 meters away from a PA at 10K, from one measurement to the next, we can see plus or minus 5 dB at 10K.
Okay.
So if I equate this to the political poll, this means the likelihood that this poll is correct would say the candidate A has got 52% and candidate B has 47% plus or minus 5 points. Mm-hmm. Boy, we're right in that range, which means we don't know what's really going to happen. It could be 56, it could be 47.
Could go either way.
Right? Yep, exactly. And so our plus or minus at 10K is plus or minus 5 dB at 80 meters in stable outdoor atmospheric conditions, which means if you see a measurement with a bump of 1 dB at 10K, you can't know if that's the reality or if it isn't. And the worst part is, even if I take a big average of those, I take a long average, it's still not much better than any given individual measurement at that kind of distance.
Okay.
Yeah, exactly. So this is a really conundrum. Like, what should we do then? Is the right approach to try to measure and EQ at high frequencies at distance, or should we work in a simulation environment and use computer analysis and our ears to take a listen and decide what's better?
Right.
And we all know that because I've actually done this many times. I've EQ'd something based on a measurement at long distance and then gone and listened to it and said, that doesn't sound good. That was a bad choice. And I end up correcting it by hand, by ear. And I go, that sounds a lot better, right? Because my ears are a little better at walking around and taking a nice smooth average, about taking a time average over 2 or 3 minutes of listening to the song. It's just dull. The whole thing is dull, right? I can't accept this. Mm-hmm. But the measurement looked great, or vice versa. I've over boosted or overcorrected. It's really bright back here. The measurement said it wasn't. And so we as people tend to look at measurements and think that they're some hard and truthful fact. But if you've used any measurement software outside of distance, we've all done the same thing, which is you watch the curve move around, and when you think it looks good, you hit store, right? And that one looks good.
That one looks good.
You know, yeah, and that's like calling up, the one street in whatever city and asking those 7 people who they're voting for. If they all live next to each other and they're all neighbors and they're all the same demographic, they're probably all voting the same way, and it's probably not a very good representation of the actual outcome of the future election, right? So the best thing we can do is take prediction. We can use the modeling environment to find the best results, especially at distance, and then get on site and verify behaviors. Hey, is it doing what I think it should do? Have conditions change from that? How do I correct for that? So that's definitely something I think that our industry is evolving towards. I know L-Acoustics is very much so evolving towards, is giving the users the tools to predict the behavior, implement that behavior on site, and then measure that behavior and figure out if that behavior corresponds to what your predicted design was.
So I wonder if at this point, are you in favor of using these multiple references? So yes, check the modeling and measure it and go listen to it?
Yeah, absolutely. I do D all of the above. I used to be concerned that, the prediction wasn't as accurate, and maybe 10 or 15 years ago it wasn't, right? Or the algorithm in the prediction software, or I think more importantly, the modeling capability of the software wasn't there. If we look at the way we did sound design 15 years ago, it was often in a 2D spreadsheet or on a 2D CAD file, and nowadays we're doing sound design and I can't tell you the last venue I did a design in that didn't have 10,000 surfaces in the model to highly accurately model the space.
Yeah.
And that's because we have 3D CADs, right? I mean, tell me a venue you've been to that doesn't have a 3D CAD or at least a really highly detailed set of blueprints. It's pretty rare. So this day and age, we can get a really good modeling behavior on the front end to understand what the predicted behavior will be with assumed conditions, right? I assume it's going to be 75 degrees in Minneapolis in October or November. I assume there will be no snow on the ground, right? And we assume it'll be humid. And if we assume those things, we can then get to some decent results.
I don't only like to share with people, like how you've done all these great things and there's these great products and things have gone really well for you, but I'm sure there have been times when things didn't go so great for you. So I wonder if you might share with us one of the biggest or maybe most painful mistakes you made on the job, and then, what you kind of had to do to recover from it.
I've made a million mistakes. I can think of, there's a couple in my mind that come flying out, and they're honest mistakes, but the consequences were nearly tragic. This was actually on a show. I believe it was on The Producers, because we were using a CADAC. And so it was, I was the A2 on The Producers, so the second audio, but the second audio still often mixes a certain number of shows a week, is responsible primarily for the orchestra pit, stage comm, and RF. That's the primary responsibility, versus the A1's primary responsibility is front of house and mix, sound check, so on and so forth. But this particular point of the tour, I was starting to be more involved at the build of front of house. It was probably also functionally the venue. I think, if I recall correctly, front of house was a pain in the butt to set up and install. And the pit was done or caught up or something. We were ahead somewhere else, so I went and helped build front of house. And so I actually went and, for the very first time, fully built out a CADAC and set it up and configured it and plugged it in. And this is a CADAC J-type, which is a common console used in musical theater 15 years ago. It's a modular frame. It's quite large. If you're listening to this and you've never seen one, you should totally look it up there. They just look super cool, if nothing else. And they sound fantastic, right? Yeah, it's a 1990s spaceship console. And everything's modular, so this is a modular frame where, as a sound designer, you could pick exactly what part you needed where. So I need this kind of an input channel. I need this kind of a output bus. And so you could build exactly your need. And we actually had a mainframe, which was probably 72 channels, and then a sidecar, which was like 36. And the mainframe then in 72 channels is probably something like 11 feet wide, 10 feet wide. Wow. And the sidecar was probably like 5 or 6 feet wide. And so, front of house was quite intimidating and impressive.
You're running across the console to get to the next channel.
Yeah. I mean, you mixed mostly on VCA, which is nice, right? And most of it was from the center bank. There's a few random pickups you had to do without that, but we had power cables, interconnect, audio cable interconnect, and there were these two cables called data bus A and B. And data bus A and B connected all the programming logic between the mainframe and the sidecar. And a CADAC was a great sounding console, and everything could be hot swapped spare in the show, middle of the show. And it was designed for this because you had to hot swap it a lot and fix things as things broke. So we carried spares of everything, and we're in Des Moines, Iowa. This is middle of December sometime, just before Christmas, and load in Monday night, set up the console. I plugged everything in. Tuesday we come in and turn it on at, probably 10 or 11 a.m. And I wasn't there at that time. It was turned on. And I'm sure everyone has ever listened or smelled when the magic smoke is released from something.
Oh, no.
And the magic smoke was released from the CADAC. And so the A1 called in the tech from the shop and said, this is what's happened. The module that actually melted down is called the CCM, which is a computer control module. And the CCM failed and incinerated itself.
Oh my God.
And we had a spare CCM, and this is important. This is the thing that turns every VCA programming on, every mute on and off, every bus routing. And by the way, I've never mixed this show manually, neither has the other person. So neither of us have mixed the show manually.
Oh, wow.
And we've lost all of our programming capability. We have a spare computer control module.
And this is because these two cables were swapped?
Well, I didn't find that out until after the fact. But yeah, these two cables were swapped, and one of them had voltage on it. And that voltage was put down the wrong pin, and it fried a resistor and so on and so forth. And a trace, it actually burnt a trace ultimately. So at some point, we decided we swapped and put in the spare CCM, turned the console back on. That one lit up in magic smoke. We realized we were really in trouble. It's 3 o'clock in Iowa, and there's a show tonight with 3,000 people coming, and we have no way to know how to mix the show at this point. And the two of us pulled the desk apart and resoldered a trace as we figured out that the data, figured out that the data A, B, and B was swapped after we talked to somebody from the United Kingdom where the console was built, and swapped that back and put that back in the desk. And that hand soldered trace and resistor replacement ran for like the next 6 months of the tour. But
amazing.
For me, the lesson learned was to, be very cognizant about how I label things, about how I address things when something as simple as the wrong cable in the wrong place can cause almost a show-stopping incident, right? And for me, I just, at that point forward, I was like, okay, everything's color-coded, everything's numbered and color-coded, everything's tested 3 times, just to be sure.
My music professor in college used to say that the worst note you can play is like a half step off. And you hear that in a lot of stories when things go wrong. And I just published another interview recently about power cable for a motor that was just like rotated 1 half step off or something, and that led to a big problem. So it's like these little things like the wrong cable, this shifted over a half, the note is half step up, sounds terrible. It's these little things that can really bring down the ship.
Yeah, and the worst part about it is a lot of times it's a very little mistake, but because you don't process or stop and go, hold on, let's work through this scenario, you start jumping to way worse conclusions. I mean, we spent 2.5 hours on power supplies, right, thinking that we had a power supply problem. And although that's important to do, we checked the power supply, and after a few minutes, it still came up good. We still spent another 2 hours on it, right? And that was 2 hours we didn't find the problem, because it's often, this sound system sounds terrible, and we start thinking it's the PA or the amplifier or the this or this, and it turns out it's an insert that's misbehaving, right? And we just spent how much time trying to figure out why this is not working right, and it's not the problem it was, and we went down a wrong path, and we're supporting this logic and belief that it must be this thing, I always think it's really important in a troubleshooting process to like just stop yourself, step back, and go, okay, what do we know? What don't we know? Identify that, and then start to figure out how can we quickly eliminate a lot of the don't knows. Is there one step we can take that eliminates half of them or more? Then let's do that step.
Yeah,
that gets us in the right direction.
And isn't this at the same time? I feel like what is so interesting about working in audio and also so scary is that now to troubleshoot an entire system from beginning to end to find the problem, you've got to know about electricity and then audio and then networking and, maybe a few things after that. So I'm just realizing, that, troubleshooting can be very complicated now with how our systems are set up.
Yeah, and it's important it's hard for anyone to be an expert at all things. And I think that's an important part of career growth, is to identify what you can or want to be an expert of, and then support yourself by surrounding yourself with other people that reinforce those skills and not reproduce them, right? So, if I'm the expert on this aspect of our system, and I can work with someone else who covers that aspect of it, then I need to trust their abilities and their judgments. However, we both need to be very cognizantly aware, because you tend to always think that your expertise identifies the problem more. It's like, the car mechanic, turns out he always thinks it's a mechanical problem, and this person always thinks it's an electrical problem, because that's their level of expertise, right? But if we can work together on tasks and problems, we can usually figure out real quickly, it can't be a networking solution because control's getting through. So if control's getting through, then we know the network's fine, or control's not getting through. Maybe it's a configuration issue. And so I think it's better to figure out what you like and hone down on that expertise, as opposed to trying to cover every single base and know every little thing. I'm not a genius on networking, but I know enough to be dangerous, and that's probably almost worse than
because you think you know the answer.
Exactly. Just because I can configure my Apple Airport Express at home doesn't make me a network genius.
All right, Scott. So a bunch of people sent me questions from Facebook. We'll see which of them you want to talk about.
Sure.
And as I already mentioned, I don't have experience with a lot of L-Acoustics equipment. And so I may have to just put some things out there, and then we'll sort of like see how we can approach it.
Sure.
So Kevin Atkins wrote, during a demo I attended for Elisa, Scott made a claim that it addresses the problem of comb filtering in system design, but didn't really expand on it. I'd be curious to hear him talk about this in more detail. So we also talked about this a little bit when you were here in Minneapolis, talking about sources, instruments coming from a single source instead of being duplicated out of multiple sources, and then your ears are hearing them. So yeah, can you speak to his question there?
difference here, like if we directly compare Eliza to a stereo sound design. So for your listeners, Eliza is a new format of sound design. It's a new way to mix shows, and it's a new way for audiences to experience much higher detail, resolution, accuracy, localization of a performance on stage or in, a play or a musical or a special event. In Eliza, what we're trying to address are a number of the issues with traditional sound design, predominantly ones of localization and intelligibility. And those come from two fundamental problems. The localization problem is we often put speakers adjacent to the stage and not where the performance is. So we put a speaker stack on left and right. And then we mix in stereo, and your listeners won't see my air quotes when I say stereo, but we mix in stereo. The reality is most of the stuff we mix in is actually dual mono. So we center pan the lead vocal. Let's just stick with that today for our analogy. And that center vocal panning means that the same correlated signal is coming out of house left and house right. So a correlated signal is one that has the same phase response and the same transfer function or magnitude response. And those two signals, when combined in time, will sum perfectly. However, those two signals, as you move around, will interfere with each other anywhere that the time is not identical, which is everywhere that is not perfectly in the middle, right? And that comb filter is created across the venue for everyone who isn't sitting at the mixing board or directly in front of them, when the mixer is in center, of course. And Eliza solves this by two things. One, we don't put the same correlated signal out of multiple speakers, right? So we have a couple of different techniques to mix, but one of which is we can pan an object across this soundscape of multiple speakers. So I might have 5 or 7 or 9 arrays across the front of the stage. And as I pan it across, it's predominantly coming out of one set of speakers. And if there's information coming out of multiple, it's decorrelated. It's not the same information. And by not being the same information, there is no comb filter between those two things, right? It's, if we go back to analog, or let's say analog, two violinists can both play the same note and they don't generate a comb filter because they're distinctly different, even though they're playing the same note. Two people in a choir can sing the same note and they don't create a comb filter because they're distinctly different. And so as soon as we start doing that, we don't have a comb filter on any of these things, no matter where we place them in our mix, pan-wise. And that's a huge difference. And I can tell you, you can probably agree with me now, once you've heard it, it's hard to unhear that.
Sure.
You walk around a venue and go, everything's just remaining consistent as I move. It's not modulating and changing. You don't realize that modulation and change exists until you pull it out of your mix.
Yeah, there's that wishy-washy sound that we're kind of all familiar with, like when they hit a cymbal or there's high-frequency information, you move your head from side to side, and the timing between those sources changes, and there's like a noticeable pitch in the comb filter.
Yep, exactly. And comb filters are the most obvious in the low end. They're the most detrimental in the low end. Your ears perceive them at the low end even more, right? As we go up in frequency, your ears are more willing to accept a comb filter. But in the low end, it's the most obvious, right? If I have a left-right substack and I walk just off a center, it's highly detrimental. That same thing is happening at every single frequency. It's just less and less detrimental, and the valley that is the nasty part of the comb filter is less wide.
Okay.
But it still modulates the tonal response, right? Mm-hmm. So it's still affecting the way the voice sounds. It's still affecting the way the bass, upper strings of the bass sound, even though it's not as blatantly obvious as the low end is.
Haniel Trisna asks, or says, explain the idea of boosting high mids in the middle boxes to air compensate for long throws instead of the top boxes generated by auto FIR in sound vision. So I imagine he's talking about an array of speakers, and there's some different processing happening to whatever, sort of boxes are in that middle zone.
Sure.
You understand what he's asking?
Yeah, I think.
Okay.
Yeah, absolutely. I totally get where this question is coming from. So first off, Sound Vision is our 3D modeling environment. Those of you who haven't used it, you can actually download it for free from our website, and we've got a database of something like 2,000 rooms online you can pull off and design your favorite PA.
Cool.
Within Sound Vision, we can implement in functionally infinite number of loudspeakers until your computer runs out of memory, right? So you can design the coolest sound system that'll never be deployed. But inside of that, we have some auto solvers, and the auto solvers are computer algorithm to help you find the best first mechanical deployment. That one's actually called auto splay. And then one that applies equalization to create the most normalized result on the best mechanical deployment, which is called autofilter. So that's actually what's being referred to here as autofilter. And what autofilter does is utilize the available FIR filtering in the amplifier to normalize the HF result across the audience. Okay. What's odd about this, and it's odd until you take our second level training seminar, variable curvature line source optimization, is that the behavior of a line source is functional on its physical deployment. And what can happen is as you get towards the edge of any line source, the amount of contributing information starts to diminish. So this is a tough thought experiment, but if you will, imagine with your arm, holding your arm out in front of yourself. And as you hold that arm out in front of yourself, you're drawing an arc, and everything that you can kind of touch is the things that you get to hear at a given position. Okay, so with a line source array, you're never just listening to a single speaker. You're actually listening to a contribution from that speaker that's pointed at you and the neighboring speakers. And now, depending on the frequency, you listen to more and more of those speakers. And the reason is the wavelengths get longer, so the things that are in phase with you at that given position are more. So in the middle of a line source array, you listen to the speaker pointed at you and a certain percentage of its neighbors. And so, if you will, you have the stuff above your hand and the stuff below your hand as you're pointing in the middle of the array. And so if you remember from our physics class way back when, if you double the number of speakers pointed at you and they're in phase, you get plus 6 dB. Okay? So if I take one sub and make it 2, I get 6 dB. If I listen to a line source array, the speakers above and below where I'm pointing gives me plus 6 dB. Well, when you go to the very edge of the array in the back, and you point your hand at the speaker that's pointing at you, it's now like the top speaker, maybe the one below it. There's nothing above you. So you're missing the low end, because the low end and the mid you're missing, which means if I boost the highs too much back there to compensate for air, I out of skew the balance, right? So I'm missing mids and missing lows, so I actually don't have to boost the highs as much to make an even tonal response. Now, what that might mean is I lose overall SPL at the very edge, but I maintain tonal consistency better. So within air compensation, dealing with the loss of high frequency due to the throw through the air, right? We can compensate a bit less at the very edge on top so that we keep more consistent tonal response in comparison, albeit we sacrifice overall SPL.
I see. So we're getting low-mid contribution from many of the boxes that's kind of coming out of the geometric midpoint of the array, but then not at the edges, the top and the bottom. And so therefore the filter's in the middle. Okay.
Yeah, there's more filtering in the middle. So what you'll often see the algorithm do is the specifically the one that's most obvious is called air compensation. It's a filter that is designed for air compensation. And say the middle of the array or the top third position of the array, it's at a 7 or an 8, but you go to the very top circuit and it's at a 2 or a 3. And it seems strange because it's throwing further. You would think you would want more of it. But if you apply that boost there, you'll skew the balance from your tonal response too much at that point because you're missing mid information. So if we push the highs even more, then we'll throw even further out of whack in terms of that tonal response.
Got it. Henny also wants to know where they can learn more about this. So is there some training they can do online, or should they go to an in-person class for the auto FIR and auto splay functions?
Yeah, there's some decent documentation within SoundVision to help you learn how to use the tools functionally if you want to learn how to use them more on a conceptual level. That we do hold training seminars actually around the world. This year, 2019, L-Acoustics globally will probably hold something like 200 seminars around the world. So they're all over the place. They're often very regularly at our office in California, also in Paris. So those are the two places in the world. There are a lot. If you happen to live somewhere else, obviously that's a bit more challenging. But our website, we do post all the public trainings we do, and you can sign up for them and register online.
Jan Weiss Moisidis wants to know, are you ever going to produce a Mac version of SoundVision?
Yeah, we did. We've got a Mac version of everything.
You do?
It's
okay.
ready to go. Yep.
All right, there you go, Jan. I guess I should have fact-checked your question first. All right, I'm going to give this one a shot. Primoz Bozelli. Are they working on vertical processing for their line arrays? So I asked him what this is because I don't really know what he means by vertical processing.
Sure.
Do you understand what he's getting at there?
Yeah, absolutely. Okay. So by vertical processing, a number of manufacturers in the market have utilized computer algorithm to optimize the response in electronics of the output of a line source array. And that's actually a technique L-Acoustics does as well. They all have different branding and technologies and terms. The thing that's different about what L-Acoustics is doing is ours actually starts with an optimization algorithm for the mechanical distribution of energy. Right. So the first one is called auto-splay, and auto-splay will actually find the best mechanical distribution for your objective and target. And your objective and target is my coverage map, my SPL distribution of my coverage map. So within our sound vision modeling software, you can define your start coverage point and your stop coverage point. And you can also define a reference point, say front of house. Once you've done those three things, then you can also define the SPL increase allowed from the reference forward and the SPL decrease allowed from the reference backwards. You can set those to be 0, right? But you could also say, for instance, at Bon Iver, I was willing to accept it to get 3 dB louder from mix forward, and I was willing to let it get 3 dB quieter from mix to the back of the room. It seems like a reasonable thing if I'm sitting up in an arena and I'm 85 meters from the PA for it to be 3 dB less loud than mix. That seems totally fine. And if I'm in the first row, 3 dB louder than mix seems very fine. Sound vision will actually then use a solving algorithm to find that mechanical distribution that gets you closest to that target without causing detrimental artifacts to the outside of the coverage zone. And then the second layer on top of that is that thing we were just talking about, which is auto filter, which is an optimization tool that solves for the best linearity in the HF response, so consistency in the HF response across that audience as well. Both of these tools, however, we still give the user access to the filtering or the mechanical distribution, so you still have the control. I like to say it's like, we use that term auto, it's like autopilot for a plane, right? The plane's set to autopilot to land, it's going to do its thing, and 99.5% of the time it's going to be spot on. But the reason that you are there as a systems engineer or a sound engineer is to take over when the automatic things aren't perfect. And so what we want the user to be able to do is realize that it turns out that I forgot to put in the model, or the design was wrong and it's too bright here. I want to turn that down. So you can still go in and correct that after the fact on site.
Nice. So you can use these tools, but then you can always edit the results later.
Yeah, of course. But all of these tools are a lot better. Remember, we were just talking about how to think about a line source array and how we think about the energy you listen to. And what a computer's good at doing is saying, wait a minute, I'm here. Here I hear this loudspeaker that's pointing at me, and I also hear these 7 neighbors at that frequency. I hear these 5 neighbors at that frequency. I hear these 2 neighbors at that frequency. And what impact does this EQ have on this position, and what impact does it have on all the other positions? And so that's what an algorithm can do. It's really hard to do that manually. You have to have a lot of time in your hands. And also, it's hard to know if you're going to come to the best conclusion, right? You'll come to a conclusion, but it might not be the best one.
So Callum Young is curious about where do products come from? What is the life? Did they get made, designed mostly in models, in computers, or through practical trial and error? So he says, I'd love to know what sort of measurement, equipment, facilities, testing procedures they go through while developing new units. Is most of the work and decision making done in simulation software pre-building prototypes, or is there more extended testing, voicing of units? ?
Yeah, I think that's a great question, and I think the answer in this case is D, all of the above.
Okay.
So L-Acoustics as an organization, we actually have a fairly small portfolio of loudspeakers. It's a little over 20 different SKUs of primary SKUs. We might have an install version that's the same acoustic design minus some rigging elements. But we actually have an R&D team north, right about 70-something people. And so if you think about that, we have 70 people dedicated to help build the best loudspeaker systems possible, and yet we only have a few new loudspeakers a year. So we spend a lot of time building these. And a lot of it does start now in computer modeling environments, and most of these are ones we've actually developed ourselves. So we've actually developed our own vibrational analysis software, and we've done this because we couldn't find anything that worked as we wanted it to, and this helps us build speakers that are acoustically as good as a classic design, yet they're much less weight, right?
Okay.
And so we're actually able to look at, say, the way a speaker cabinet vibrates based on the sound pressure being injected from the transducers in the acoustic design, and figure out where we need to have a stronger enclosure and where we can reduce mass. And so In the acoustic side of things, this is something that gives us a significant advantage, that our speakers still sound really good and yet are lighter than just about anything else on market. A K2 is the prime example of that. A K2 is the same SBL capability as a VDOSC. It's pretty much only thing louder on it than a market is a K1, which is another L-Acoustics loudspeaker, and yet a K2 only weighs 123 pounds, right? And it's half the weight of that original VDOSC, and yet it's the same amount of power. So that's a big thing there. We have a modeling software we've developed ourselves, a computational fluid dynamics software for modeling the airflow of a bass reflex port, right? Because once again, nothing at the market worked as we needed it to model the way the air comes and goes through a vent of a loudspeaker. And this kind of optimization allows us to build virtual models and then confirm with prototypes. So this is the way we iterate. We concept something, we have modelization, we're going to build a prototype to verify and confirm what we believe to happen, and then we iterate from there. We do have templates for response, so that K1 and a K2 sound very similar. We actually have methodologies for building the preset behavior. And that preset behavior is a compromise between the performance in front on axis versus in front in polar versus off axis. And we have to make sure that a choice we make for in front on axis doesn't detrimentally affect what happens behind or to the sides. And then we also have a team of R&D and application engineers that will critically listen to every preset. And beyond that, we often deploy these in beta processes, whether publicly or privately out in the field. So there might be situations where someone from L-Acoustics is somewhere to help try out a new preset in a real-life situation to make sure it translates as we expect it to. And we really want to make sure that when we deliver something to the end user in an official capacity, it's at the highest possible quality and consistency for everyone, so that they know they're going to have a great show.
So Scott, you have been to a lot of music venues in the world, and this Bon Iver tour, for example, you are seeing a lot of arenas. So my friend Steve Knotts wants to know, if Greek amphitheaters were designed to put audience in the best place for sound, why are they not creating clubs, theaters, and control rooms in similar architectural style? Any thoughts on that?
That's a great question. I have a couple of thoughts. I have no idea if there's any truth to them or not. I guess we don't have to anymore because we can amplify sound now. A Greek theater was a solution to the problem, right? The problem is everyone has to have a good visual seat and a good listening seat. So we have to build it in this way. But we can amplify sound now, and we can amplify video, right? Images now. So we don't have to do that anymore. I would also say the second thing is, if you've been to a modern show these days and had the sound system off, you'll notice the noise floor in the venue is probably still excessively loud compared to what it was 2,000 years ago, right? The noise floor 2,000 years ago was Mother Nature. That was it.
No planes.
And now it's
no HVAC
no planes,
system.
no HVAC system, no moving light fans, no video wall fans, no
bars,
cell phones.
Well, maybe there were bars, but different kinds.
Yeah, exactly. So I think part of that is that scenario for sure, is that we now have to think about how we get over those noise floor things. Hey, if the noise floor is 75 dB, I can't mix at 75, right? I got to mix at 85 or 90 to be comfortably over that. I think the other thing too is the expectation of what a show is changes over time. I was amazingly satisfied of my VDOS deployment in 2000 or 1999 with an Excel spreadsheet. I have a feeling if I could hear that design now, I wouldn't think so highly of it, right? So I think the expectations for what a show is have changed.
Sure, we don't want
I would hope
great
they have.
sound anymore. We want magic sound.
Yeah, exactly. And I don't want to see speakers.
Right.
Invisible. Yeah.
Okay, so Roy Sputz wants to know about stereo. We maybe started talking a little bit about this with the Lisa system, but he wants to know, is the idea of true stereo and live sound a myth? So I guess by true stereo, he means that you're in a position where with level and time, you can have a phantom source and like move it across, the horizontal plane. So is that a myth?
Yeah, I mean, for sure. So the classic panning of your mixing desk is an amplitude panner between two output buses. And if you are sitting in the middle, you will or can perceive a phantom center from a center panned object. However, if you're sitting 10 or 15 feet to the left of that, you will perceive the house left PA 10 or 15 milliseconds early, which will all but negate the energy from the other side. Doesn't matter. In fact, you have to pan pretty far, and this is a fun experiment to do, how far you have to pan before the object will actually, it won't go to the middle, it will jump, right? So this is the way you can tell that stereo isn't working in that way, is that objects don't glide as you pan them, they actually just jump from side to side, right? So in the very center, you can pan something and perceive it to move over, but for everyone else in the venue, they still hear it on the side that's closer to them until you pan it really hard. So, that 30% pan you do on the cymbals, everyone doesn't actually hear that unless they're right in the middle. Everyone else still hears the cymbal on the speaker that's closer to them because that one arrives 15 or 20 milliseconds early. And we know this. Rhetorically, we all know this because we all don't use the pan knob at shows. Besides the keyboards and the overheads, and the reverbs, what do you pan? Right? Have you ever hard panned a lead guitar? Most of the audience doesn't actually get to hear both sides of the PA. A certain fraction of the audience won't hear the other side of the PA. And that's not the same as it is at your house. In your house or in your couch, you can hear both speakers anywhere you sit in your family room. So you can have a voice come from one side and it isn't bothersome. But as you go up in scale, it does not work, and we know that. And that's part of what Eliza is trying to resolve, is how do I sound design so that everyone can perceive the sound design I want them to, and how can I figure out who can't perceive that, and when they can't perceive that, how do I deal with that? So those are all the things we deal with in Eliza's. I know that these people aren't going to get it, so how do I manage that? I need to have something that'll help there.
Okert Marais wants to know, are they planning on supporting, number one, mic correction curves, number two, custom actual Z-weighted weighting curves on the P1?
The question is a mic correction curve. So a mic correction curve is actually an offset curve provided by the manufacturer of a measurement mic that will correct it for the design target. So this microphone manufactured on this day at this time is offset by X little amount at these frequencies. Will we support those on the P1 and within the measurement software? Yes. Time frame, I can't say whether it's 1 week or 1 month or 1 year, but at some point it'll be there. The reality is, though, that's actually not that important. And the reason I can tell you that is that conversation we had some time ago about the distribution of responses at distance. So even at 20 meters away at 10K, you can see plus or minus 1 or 1.5 dB. And mic correction curves often distribute more like 0.5 dB of offset or 0.7 dB, so it's just not that big of a deal. For sure, every little bit helps. You might as well take advantage of that. But the thing is, where that correction maybe is most relevant in the high end, it's the least relevant when you take a measurement of a system at any more than 20 meters away. What's actually a bigger deal if you have multiple microphones is the sensitivity individually of the microphones themselves. From the same manufacturer, often the offset in frequency response is negligible, but the difference in sensitivity can be quite high. So unless you specifically spend the money on a matched set, it's not uncommon for a high-name manufacturer to have 4, 5, or 6 dB of variance in sensitivity on a microphone, yet the actual response be quite stable. As far as custom actual weightings, yeah, we'll get to that eventually as well. As far as P1, M1, we have a million things we'll add there over time. I invite users who haven't done it yet, if they've got a P1 especially, you can actually download the software from our website and give it a try. Once you get used to the workflow, the savings in workflow time and organization of your data is a tenfold increase. So, the 2 or 3 things that we really wish were there that aren't there yet, you'll probably forgive us for a little while so we can catch up.
I'm glad you talked about the mic correction curves, because I have a couple of videos about this on YouTube, and they are some of the most popular things and also have the highest engagement. So people are regularly emailing me and saying, can you send me a microphone correction curve, or can you tell me more about how to do this? And what I recommend is that you actually look at your microphone correction curve. So in some audio analyzers like Sat Live, you can actually just tell it to show me the curve, and it'll put all the data on the screen for you. And when you look at it, as you just mentioned, it can be very small. And so I'm glad you mentioned that it's probably not the thing to be spending our very small amount of time on.
Yeah, and that's exactly it, right? Like, I'm sure you're familiar with the 80-20 rule, right? Figure out what will get you 80% success with the least amount of time. And those who do that successfully at show sites are often winners because they realize that you could spend all your time on the transient response of the HF of the kick drum, or you could build a balanced mix for your entire band. And the person who can build a balanced mix for the entire band in the same amount of time as the one person who spent on the kick drum will probably still have a job, right? You can come back to those little details, but if you can figure out what will get you most work done in the least amount of time, go for that. Mic correction curves are important. They're probably not tragic. You can also, by the way, a lot of them come as a text file. You can load it in Excel and just plot it on a graph. And that's not a big thing. In all reality, what is more important, especially if you have multiple microphones, is that they're all similar, right? And so usually one of the very first things I do when I measure a PA, I have a set of my own 4 mics. I have the correction curves. But the very first thing I do every day is put them all together and take a measurement of something in a similar position and make sure they all look similar. Yeah. And I don't get too worried about a half dB offset at 8K because I could have sneezed and that will cause a half a dB offset at 8K. And I could take that again and it'll probably change a little bit because remember, at 30 meters away, it's not that stable. So
Scott, I want to know what's in your work bag. I want to know what you're taking to shows, but I know we can't go through everything. So I wonder if you could pick out 2 or 3 or 4 items that you're taking that you think are either unique or interesting.
I don't carry much anymore. I carry my own calibration mics.
What are they?
I carry the ISMCOM
7150.
There you go. You got it. I carry the ISMCOMs. You know why I love those? I also have a set of DPA 4007s, which are great. And every time my DPA 4007 falls over on the ground and hits the ground, I cry. Because each one of those, I have multiples of those, and each one of those costs a cheap used car. The ISMCOMs are great. They're equally as good as the DPA at moderate SPLs, and we tune PAs at moderate SPLs. So I don't often measure my PA at 110 dB. It's just not that big of a deal. Mm-hmm. And when they fall over and break, it's like a really nice steak dinner. Mm-hmm. So it's a little more reasonable to replace. I carry a couple of different sound cards I've had over the years. One I love to death is made by Digigram. It's called the Cancun 442. It's really compact. It has 4 mic pre's on it that are really good. It has AES in and out, and it all gets power off a USB bus. I've had it for like 6 or 7 years, and it's never broken. Wow. And I'm not exactly nice on gear, so that's nice. Now I carry a P1 as well with me because I can use that to measure PAs with. If they don't have one there, I have my own. And I carry a couple laptops. Years and years and years ago, I remember when I bought my first tablet and wirelessly tuned a PA in 2002, probably. The very first generation of Wi-Fi. I thought that was pretty cool.
Sure. It's amazing.
Being able to mute something from like 50 feet from front of house was pretty revolutionary at the time.
Scott, what is one book that you've found immensely helpful?
So the one book I really like is actually a book on statistics from Nate Silver called Signal to Noise. And it's interesting because Nate Silver, if you know American politics, is famous for 538 Politics, 538.com, which is he does a lot of predictions on outcomes of elections, but he also has a background. He was a semi-professional poker player and wrote an algorithm, I believe still used to this day by Major League Baseball, to help predict the future capabilities of a minor league baseball player based on similar trends. And so he talks about the way you can identify valid information in noisy environments and understanding what signal-to-noise ratios are in data sets. Really good book. It's actually really interesting to read because as someone who tunes sound systems, we talk often about signal-to-noise in terms of data acquisition. I have a good signal-to-noise ratio on this, but it's actually also the measurement I'm taking is telling me something valid, and I have to figure that out by analyzing the signal-to-noise of this data set, right? Like, is this indication of one person telling me it sounds terrible noise or signal, right?
Sure.
And that can be based on whether that person is the producer of the event or whether that person is sitting behind a pillar. I might weight their individual contribution, and I might weight their location. if we start getting a lot of noise complaints from a neighborhood because we have off-site noise at a festival, is that signal or is that noise? Are they just complaining because they don't like the festival, or are they complaining because there's actually a problem? That's really important, because you'll often do an analysis of something in audio, and people will take this one data point and say, look, this is why.
This is everything.
I had one great show on this brand speaker, therefore it's great. Or I had one terrible show on this speaker, therefore it's terrible. And it's like, you know what? It's probably not the best data set in the world, right? One lousy rental car doesn't make that whole car manufacturer terrible. So,
yeah.
But anyways, great book, Signal Noise by Nate Silver. It's really good.
That sounds really good. I'm reading a really good book right now about how drugs finally make it through the pharmaceutical industry and so that we can use them. And a lot of the stories involve, he calls it the 3 deaths. So like a product has to fail 3 times before it can actually get there. And so there are plenty of times where like something gets tested and it's like, oh, this causes cancer in dogs, we can't use it. And then someone looks at it closer, does another test, and finds out that's not true. So it sounds like some similar information.
Yeah, that's exactly it. It's the people tend to want to choose answers. So it's like you hear about this study of 12 people came out with this result. What you never find out about is how many times they did the study to get the result they wanted.
Oh, right.
Right. Because in science, especially in journal publications, especially in sound mixes, especially, we don't hear about the 12 bad results that didn't turn out well. If someone really wants something to be a success, they're going to point out the success they had and not the 11 failures along the way. And we see the same thing all the time. I mean, a front house engineer or a mixer, a producer, a musician has their exact setup, and never along the way do they stop and pull a piece out of that setup and say, is it better with or without this piece, right? They just used it one time. It solved the problem that day.
Right, you just keep adding things. You don't take things away.
Yeah. Right. Is this a correlation or a causation, right? I correlated the success today to the adding of this magical piece of gear, but I never once checked to see if that was relevant. When I tuned PAs, I used to often measure the sound system, get it all set and ready to go. But I also actually did a measurement every single day after sound check through the lead vocal mic at mix. And I took a trace of that, because I can tell you what, a really good front house engineer will always make sure that his or her star sounds the same for them every day, right? And so whatever you do to a PA, whatever they do to a PA, I would bet you money that a really good engineer will make that vocal mic at mix sound the same every day. And it's a good way to just kind of track behaviors, right, and see where we're drifting towards. If the vocal mic keeps getting thinner and thinner and thinner, should we make the PA have more boost in it in the low end so that they don't have to chase that down, or vice versa? And so that was a common thing. I took traces of that after sound check, 5 o'clock, quick shot through that. It's 3 seconds and I had all the information I needed.
Scott, do you listen to any podcasts?
Tons. I travel too much. So flying on airplanes.
Give me 1 or 2 that you like listen to every time. Like, what's the ones that you have to hear?
I love, it's a fairly new one, 20,000 Hertz. I'm sure you're familiar with that one.
I've heard of it, yeah.
Yeah, it's a great one. I quite 538 Politics has a good one if you like politics. There's another one called Science Versus, which is a fun one that takes on all the urban myth and legend of, does this actually cause cancer? Planet Money is a great one. And Freakonomics is another great one. Freakonomics is a fantastic one. But I probably got 20 or 30 podcasts I listen to regularly. How about yourself?
Okay, so there are really only 2. And at this point, only 1, because I really only get kind of addicted or really fascinated with comedy podcasts. And I think that's where I get kind of the most dopamine. Like, I really like stories too. And there are podcasts. So there's a long list of podcasts that I like. But I'd say right now, there's really only one that I listen to every time it comes out. And I'm like, when's the next one coming out? And when it comes out, I'm like, don't talk to me. I'm listening to this. And it is The Flophouse. And I don't think people should rush out and listen to it. My wife hates it. Like, it's like a lot of people don't like it. It is like 3 guys just acting weird and talking about bad movies. But I love it, and I think it's hilarious.
Yeah, it's fun. I mean, I when I travel, I tend to listen to podcasts when I'm walking through the airport in security. I've stopped listening to them on the plane because I end up falling asleep, and then my podcast player goes through 4 episodes of something, and I don't realize what has happened. But I tend now, I get on kicks of, I found a great app that allows me to download the entire Wikipedia, and you can go on an encyclopedia reading journey click through. Yeah, it's great. It's great. So I can just start reading on a topic and decide to learn about this topic and dig through it. And then I end up with 17 questions that I have to research afterwards to find out if they're true or not. So it's quite fun.
I feel like, I don't know why this is, but sometimes working in audio can feel a little too serious. Like, we're the people that it feels like the show is riding on us sometimes, and it can feel like the show has to happen in our entire career, like nothing can go wrong, and we have to present like this face of like infallible, like we have to almost seem like we're perfect. And so I feel like a lot of times when I get home from work or I'm not working, like, oh man, I really just need some kind of release, which I think is what kind of attracts me to the comedy. I need a little bit of a break from like the science and like the seriousness of it all.
Yeah, I always remind myself, we're lucky. We do a job all of us love to do, right? We do a job that entertains others. We do a job that makes money for people. That's great. But we do make believe, right? If we make, a mistake mixing a band, rarely is someone going to die, right? It's not like what we're doing in a lot of parts of our job are that scenario. We're pretending to create an experience for somebody that will change their life for 2 hours. And the worst case scenario in that 2 hours is they don't get taken away, right? And that's a bummer. It sucks when that doesn't happen because, really you want to create that experience for someone to be entertained. But yeah, I mean, our job is make believe, and how much fun is that we get to play pretend all day long and do really cool things. But I tend not to get stressed out at shows because that's the worst. It's usually the worst case scenario, right? Is make believe didn't go well, and we can always learn from that and do a better job the next day. So for me, it's that enjoyment of not getting stressed out at that aspect of the job. I'm stressed out about finishing my presentation on time or finishing this on time or getting the work done. But once it gets to going to do shows, that's fun. I hope the band is so good that I forget that I'm at work,
Well, Scott, where's the best place for people to follow your work? Are you writing any articles for the blog or if people want to reach out to you and see what you're doing, should they do that?
Yeah, social media wise, I do a bit of Instagram and Facebook and I love to see people there. Through L-Acoustics, I do quite a lot of work in presentation there, and feel free to reach out to us on our official handles, whether it's Facebook, Instagram, or Twitter, so on and so forth. You can see me at trade shows around the world, and I do a number of presentations, and we've got a whole lot more great content coming out soon that I hope you and your listeners will enjoy and learn from.
Well, Scott, thank you so much for joining me on Sound Design Live.
Thanks for having me, Nathan. Appreciate it.
Sound Design. So a student of mine sent me an email yesterday, and I could tell that they were really struggling. They had taken one of my courses, Priority Workshop Seeing Sound, and they had even taken someone else's course, and yet they were still struggling. So here's what it says in the email. I'm really just at my wit's end with this. About $3,000 into an investment to try and learn something and can't find a resolve to a simple ask for the most basic help. I've started and quit 2 courses, including yours, both labeled as for beginners to experts, but I still don't even know how to patch anything together to do a basic measurement. I'm ready to give up. And here is what I wrote back to them. Stop taking courses. Okay? The definition of insanity is doing the same thing over and over again, expecting a different result. My guess is that these aren't working for you, not because they're bad courses or the information is bad, but just that you need personalized instruction. You're swimming through these giant bodies of information, hoping that the answers will appear instead of going direct. So courses like mine can't be perfect for everyone, but at the same time, they have to be broad enough to be helpful for most people. So it's pretty clear to me that you are stuck because there's some piece of information that you need and you're just not finding it. And it's like going through an encyclopedia or a dictionary, but not really knowing what you're looking for. And it would be so much faster and save you so much time and even money potentially if you could just meet with someone directly. And There are several ways that you can do that. You might have a friend who's an expert in this thing and who would just trade you, lunch for a day of training. You can ask in online groups to see if there's anyone nearby who would meet with you. And I've even known people who will just call up a local AV company and say, hey, do you know anyone who knows how to do this thing that I need to learn? So I recommended that they meet with someone in person, and if not, with me online. And he chose both. So we met over video chat, and within an hour, he had his audio analyzer set up properly, took his first measurement, and left with some solid next steps for moving forward. And I think sometimes you just need another pair of eyes on something. There's something you're not quite seeing. There's some gap in this knowledge that you need. And sometimes private training is actually cheaper and faster than group training. So while you might pay $500 for Pro Day Workshop Seeing Sound and hope that your question might get answered over its 65 lessons, you could also, buy 3 private trainings from me for $300 and you'd be guaranteed that your question would be answered, assuming that I know the answer. So when I saw how helpful this was for this one person, I realized that I'd like to do more of this. And so I've put together just a simple package of these private training sessions. So as I mentioned, normally 3 one-hour sessions with me would be $300. So I put together a package of 3 hours of private training for $240. So that's $60 off, and then you can split up that time into whatever you want. So you could do 1 3-hour session, we could do 3 one-hour sessions, or 6 30-minute sessions. Now, normally this is online, and that works best for most people. We just get on video chat, and we can go through whatever problems that you're having. Or if you want to come to Minneapolis, or you're here already, I'd be happy to meet you in person. So if you're interested in private training, I hope you will pursue it, even if it's not with me. If you want to train with me, send me an email, nathan@sounddesignlive.com, and I'll send you the link to buy this package. Or if you're driving right now, just tell Siri to text me, 747-666-5768. I'd like to thank Bodo Felush for the music in today's episode. If you want to find more of his music, you can do that at unvirtualmusic.com. That's unvirtual-music.com. Sound Design Live is supported by Learn Stage Lighting, Scott, Pedro, Ryan, Bob, Martin, Roadie Free Radio, Joel, Ellis, Jim, Sinqui, Terry, Nicholas, Kuba, Chris, DC Sound Op, and Dave. You can start supporting Sound Design Live for as little as $1 today at patreon.com/sounddesignlive.